Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 1, Section 5, Measuring Segments. So we start out with the ruler postulate. So the ruler postulate, notice this postulate has a book name, so most people recognize this is the ruler postulate no matter what book you use. This one says the points of a line can be put into a one-to-one correspondence with real numbers, so the distance between any two points is the absolute value of the difference of the corresponding numbers. So this is a really easy idea. It seems like it's worded in a difficult way, but basically what this is saying is, so what we can do is we can take a line and we can put it on a ruler or something like that, a measuring device, and we could take any 2 points, and when we put it on the ruler, those points are going to line up with numbers on the ruler. And if we want to find the distance between the points, it's just the absolute value of the difference of the corresponding numbers. Absolute value because it doesn't matter if we take the smaller number and subtract the larger number, distance is always positive, so we want it to be a positive number. So it's the absolute value of the difference of the corresponding numbers. So that's the ruler postulate. Now, if you notice here, they give you a line and they have points A and B, and then they have little a and little b. What they're saying is that A and B represent values. Okay? Big A and big B are the actual points, but little a and little b are the values assigned to those points based on putting them on a number line or anything like that. So they're saying that the distance from A to B is the absolute value of either B minus A or A minus B. Now we have congruent. Congruent segments are 2 segments with the same length. And one of the first things that we really want you to understand is the difference between equality and congruence. They are very much related, but they are not the same thing. So if I take a look at these 2 pictures, and I've got AB, and AB is labeled as 2 centimeters, and CD is also labeled as 2 centimeters, I can say that AB is equal to CD. Now notice what I did not do. I did not put segment lines above those, because what I'm saying is I'm saying the value. This means the distance from A to B. So I don't have to write it out every time. And this means the distance from C to D. And notice I can use equality because I'm not talking about the segments are equal. I'm saying that the length between the 2 points on those segments are equal. Now, notice the next picture. Same segments, and then we have, these are called congruent symbols. Okay. As long as we put the same number of tick marks on each line or segment, then we can say that they are congruent. Now, according to this picture, I can say that AB is congruent to CD. And notice, I put the little segment lines. So even though these are related, because if 2 segments are congruent, then the distances are equal. And if the distances are equal, well, then they're congruent. They are technically the same, or different things that we're talking about. This one, we're talking about numbers, measures. This one, we're talking about segments. Segments are congruent, numbers are equal. So please be careful, do not mix these up. Do not put congruence when you're talking about the measures. Do not put equality when you're talking about the segments, unless you really mean the segments are the same in the same spot, they're the same segment, which we're not going to deal with in this course. Okay? So find AB, BC, and R, AB, and BC. Okay, so very easy problem, but notice the notation, because this first chapter is all about notation. Okay, so what I'm going to do is I'm going to say, well, let's find AB. AB, no segment line because I'm talking about the distance, is the absolute value of negative 8 minus 5 minus negative 5. Be careful. Up. Negative 8 plus 5. Negative 3, which is 3. And I know most of us could have done that very easily, but really I just want to see you see the process. Okay, so AB is distance 3. Okay, now the other one, BC. BC is the absolute value of negative 5 minus negative 2, which is the absolute value of negative 5 plus 2, which is the absolute value of negative 3, which is 3. I don't know why I put absolute values here. Sorry about that. So BC is 3. So now what I can say based on that, can't go right to their congruent. AB equals 3, BC equals 3, the distances are both 3. The next thing I can say is I can say that AB equals BC. Notice, still no segments. Because they both equal 3, then the distances have to be the same. And then what I can say is, therefore, AB is congruent to BC. And if you kind of say, well, of course it's true, absolutely, but really in geometry what we're trying to do is mathematically get there. And you can't use, but of course it's true as a reason. Okay, so notice I found algebraically their distances. The distances are the same, so I said that the distances are equal, and then I can say, well, because the distances are equal, then they must be congruent. This is one of the most important postulates we learned, segment addition postulate. You will see it so much, we get so tired of it. Also the angle addition postulate, also get tired of, but here they are. If 3 points A, B, and C are collinear, and B is between A and C, then the distance from A to B plus the distance from B to C is equal to the distance between A and C. Notice, no segment lines. I'm talking about distances. This is all distances. Not congruent. So here's an example of using it. If dt equals 60, find the length of x. This is one of the ones that when you see on the worksheets we'll give you, they're going to be a lot harder. You know, there'll be systems and quadratics and things like that. But the book, not many quadratics, not many systems, so most of the examples from the book will be much easier. Be careful when you're setting up a statement. Don't immediately see two things and go, oh, equal. Look at what you have. You need to write something based on what you're given. Well, I'm not given that anything's equal to each other. I am given that dt is 60. So that must be true that if I take ds, 2x minus 8, and I add to it st, 3x minus 12, sorry, that's a 3, it should be equal to 60. Really what I'm doing based on this segment addition postulate is I'm saying that I can take ds and I can add st, and that's going to be equal to dt. And I could write this in any proof, and I could say that's the segment addition postulate. Okay, once I do that, now I can solve it. So 2x and 3x, that gives me 5x minus 20 equals 60. Add the 20 to the other side. X equals 1 and 6, so 16. Wants me to find x, then wants me to find ds. So it's going to be twice that 16 minus 8. So I'm looking at 24. And this one 3 times that, so that's going to be 48. Minus 12. So that's going to be 36. And if I add those together, just a quick little check, do I get 60? Yes, I do, so I'm pretty confident. So don't leave your answers written all over the place. I'm going to write x equals 16, ds, the distance from d to s is 24, and the distance from s to t is 36. Midpoint. We all have an idea of what midpoint is, but one of the things you're really trying to do is look at the book definition, because if it says congruent and you write a statement that says the measures are equal, then you're not using the definition correctly. Okay, so you need to know what definitions say congruence, what definitions say measures are equal. You need to be very specific about what the definition says. Don't use your prior definitions that you learned in 5th or 6th grade. Okay? Make sure you know what the book says. So midpoint, a point that divides a segment into two congruent segments. So suppose I draw a line, and I'm going to put 3 points on it. And I tell you, this has to be a given or something that you find, B is the midpoint, and I always abbreviate midpoint, MP, of AC. So put given. What I can use the definition of midpoint to do is I can then there say, well, because of the definition of a midpoint, I can say that AB is congruent to BC. And if someone said, well, how do you know that? I can say by definition of midpoint. I cannot go right to the distances between A and B and C are equal. Now, I can get there because I can use definition of congruence, but that would be 2 steps. First using definition of midpoint, then using definition of congruence. So another algebra problem, pretty quick. So C is the midpoint, find AC, CB, and AB. So in this case, double check, we're not adding anything, we're given that it's a midpoint. So you don't, if it's an algebra problem, you don't have to write this out, but because is congruent to CB, definition of midpoint, I'm going to say that AC equals CB, definition of congruence. If 2 things are congruent, if it's now segments. If 2 segments are congruent, then their measures are equal. And then what I can do is I can say, well, then 2x plus 1 equals 3x minus 4. And if I was doing this in a proof, that would be substitution, property of equality. All I'm doing is taking out the AC and putting in what the value is, and then I can solve. Now I'm not going to write the rest as a proof. We're not there until like end of chapter 2, but I'll continue algebraically. So subtract the 2x to the other side, add the 4, so that would be 5 equals x. And then if I plug this in, this would be 10 plus 1 is 11, and this one would be 15 minus 4 is also 11, so good. And so AC is 11, CB is 11, and AB is, add them together, 22. Okay. Now, if I was doing this, this was problem on a test or quiz, you would not have to do this part right here. Okay. We're not there yet. If this was a proof, I would have to do a whole lot more than what I just did. But I kind of wanted to get you this idea of thinking about how do we get there in a very logical way. So I kind of did a quasi-proof. And that's it for today's notes. Thank you for watching. Have a great day.